Hi, my name is Shovan Dixit, and today I will be talking about how flies move horizontally in the direction of a light that is shined on them. So this is to test how well the flies move and possibly the effects of various diets on their movement. So the setup we have here is we have a wooden stick with a paper with centimeters markings up to 25 centimeters, and we have a plastic tube with a light on one end and a stopper on the other. And the lights are different because one is, as you can see, this one is brighter. It's not covered with paper, so the flies may not be as attracted to it because they don't like the bright light, and they may be confused. As you can see, it kind of reflects off the surface of the paper and the wood. And this one is covered with paper, and they will be more likely to move towards it. So we just place that back in. Okay, so before you start testing, make sure to either turn off the lights in the room or dim the lights so the flies aren't confused, and the only source of light that they are shown is the one that is shown by the flashlight in the tube. And now we start the tests. So as you can see, we have flies in one of these tubes. So you knock them down. You have your timer ready. That could be a phone, a stopwatch. And you time them for about 10 seconds. So make sure they're all down. So you time them for about 10 seconds. See how far they move. Okay, you stop your timer, and you can, if you have multiple flies, you can put your fingers at where you see the flies stopped at or where they were at the 10-second mark. And then you come over to your table that you have set up. So you have distance traveled in 10 seconds, and you have various diets, so such as 25% fat, and the number of flies in one column, and then you write down how far they went. So this is in centimeters. So for instance, one at the 10-second mark, one moved about 13 centimeters. So for this one, you'd write 13 centimeters. Okay, so once you've collected your data on this table, you can go ahead, you can make a graph of the various diets. So you graph distance traveled on the y-axis, and remember to put centimeters, and then you put the number of flies on the next axis. So you go the first fly, the second fly, and the third fly, and you plot those points, how far they traveled. And then you can, for your fourth point, you can plot the average. So you put a dot somewhere in between those points, and this line right here represents the range of the distance that they traveled. And so, for instance, this graph could be the one for 25% fat, and then you can do another one for 10% fat, and then you can compare the averages, the ranges, the standard deviations of how far each diet affects the movement of the flies towards the light. And you can kind of do an analysis, a statistical analysis, and see possibly which diet maybe hinders how far they move, which diet may be the best for them in terms of movement. And it seems to be this could be the best way to kind of compare the different types of diets. And you can see maybe possibly which diets or which flies maybe are sick. So for instance, this metabolic syndrome that can cause high blood sugar, which can also cause blurred vision. So blurred vision, obviously they won't be as sensitive to the light, so they won't be as attracted to the light, so they won't move as far. So plotting the points, maybe you can see which flies could possibly have this illness, or which flies maybe don't. And yeah.
Here we go.
So now you can see the setup is vertical. So there's two factors in play here. There's the response to the light and a geotactic response. So the flies having to move vertically, they expend more energy than they would if they were horizontal. So it's the same, you knock them down and you would remember to have a timer ready, and then you would time for 10 seconds how much they moved. So remember, these are centimeter markings. And then for various flies you would, or for multiple flies, you would maybe put a finger where you saw them at the 10-second mark. And then for after you collect, or after you observe their movement, you would again make a table, and this time it's a vertical distance traveled in 10 seconds. And you'd make, the table would be set up the same. You'd put the various diets, you'd put the number, the fly number, so 1, 2, 3, and then you'd write down how far they moved. And they may not move as far this time because they have to expend more energy. And then, so again, you make a graph, so of the different diets, and see which one. So doing that, making a graph, you can see which diet maybe gives them more energy. So maybe a 25% fat or 10% protein, maybe that'll give them more energy to move vertically. And that's another good way to compare which diets are kind of best for the flies. Another way you could test is by gender. So you could say, you could have females in one tube, so we have two setups here, and males in the other, and you can separate them using a microscope. And the females have to carry the eggs, so they're a little bigger, so they have to expend more energy. And you may observe that females don't move as far as the males because of what they have to carry and the energy, the extra energy they have to use to climb this vertical ascent. All right, so now the lights are off, so you knock them down, and their only source of light is the one at the end of the tube. And as you can see, they are crawling. If they are crawling very rapidly, or they're crawling towards the light, they're attracted to the light. And so the difference is, if before we did it with the lights on and they didn't move as far, they did move, but they didn't move as far. And now you can see that they're pretty much climbing or crawling all the way to the top of the tube.